Alright guys, so in section 11.5 we're going to be talking all about what are called inscribed angles. And keep in mind, inscribed angles are different from central angles. So central angles had their vertex at the center of the circle. We're now going to have an inscribed angle where the vertex is going to be on the circle itself. So I want to make sure that you understand that there's a difference between these types of angles and the ones we looked at in section 11.4. Okay, so yeah, definition of an inscribed angle: it's an angle whose vertex is on the circle and whose sides are chords for the circle. In other words, looking at this diagram in the center here, we would say that angle ABC is an inscribed angle. So then an intercepted arc is going to be the arc which is in the interior of the angle. In other words, this arc right here from A to C would be our intercepted arc. So then how we're going to be able to use this, there's a relationship between the inscribed angle and the intercepted arc. And so the inscribed angle is half of the intercepted arc. In other words, in this case, if we wanted to find the measure of angle 1, that would be equal to 1/2 the measure of arc AC. Now, if two inscribed angles have the same intercepted arcs, then the angles are congruent, which should kind of make sense. So again, if they have the same intercepted arc, then they're going to be congruent to each other. In other words, if you've got angle 1, which has the intercepted arc AC, and angle 2, which also has the intercepted arc AC, then angle 1 has to be congruent to angle 2. Alright, so let's work through some example problems here. On this first example, we've got our circle, and we were looking to find x. So it would be really nice if we had this measure of our arc right here in blue that I've highlighted for us. And while we don't have it yet, we can find it pretty easily if we take 360 minus the other two arcs, so minus 156 minus 130. That should be 74 that's left over, which would be the measure of this arc right here. So then if we want to find x, well, that's pretty easy. X is just going to be equal to 1/2 multiplied by 74, or 1/2 of 74. And that's going to be 37. And there's the measure of our angle. On this next example, we're actually given a central angle as well. So notice that our central angle is 102. That means that this arc is also 102. So to find the measure of angle x, we're just going to take 1/2 of that number, so 1/2 of 102, which is equal to 51, and there would be the measure for our angle. Okay. For this next one, let's go ahead and find each of these variables. So let's start with y, since that'll probably be easiest. Y is just going to be 1/2 the measure of that angle, or that arc there. So the measure of angle y is 1/2 of 30, and 1/2 of 30 is 15. There would be the measure of angle y. Next, let's go ahead and find x. So to find x, we would have to take 180, since we're looking at a semicircle, minus the 130, minus the 30. That leaves us 20 degrees left over. There is x. So then to find z, we'll just take 1/2 of x. So measure of angle z is 1/2 of 20. So it looks like the measure of angle z is going to be 10. Okay. So once again, let's go ahead and find our missing information. So we'll look at x, y, and z. All right, so starting with y, and we're looking for this arc right here. We know this angle is 35, but we know that that would have been half of what y is. In other words, that 35 degrees is equal to 1/2 y. So what we need to do is we need to multiply both sides by 2, and that should give us y by itself is equal to 70 degrees. So when you're going the other direction, you're just going to basically double each of the numbers. So then using that information, we can find the others pretty quickly. To find x, we would just double this 75. So x would be equal to 75 times 2, and that would be equal to 150. So again, when you're going the other direction, pretty easy to do that. Now the one that we don't have yet is z. And to know z, we need to know what this angle is. To find that angle, we need to now go ahead and take 180 minus our other two angles. And what that'll leave us with is 70 degrees left over for that angle. So then z would be equal to 2 multiplied by 70 degrees, which then is going to be 140. All right. So now let's go ahead and work with some other variables in here. We'll make them a little bit more interesting. So on this next example, we've got our angle, which is 7x minus 8, it says, and the arc, which is 12x plus 2. And so we know that the arc has to be double whatever our angle is. In other words, our 12x plus 12 is equal to double, so multiplied by 2, what our angle is. So 2 multiplied by 7x minus 8. And now we just go ahead and solve for x. So let's go ahead and distribute on the right side. So that would be 14x minus 16. And then the 12x plus 12 still on the left. And now we'll go ahead and solve for x. So I'm going to move all my variables to the right side. So we'll subtract 12x. So that'll be 12 is equal to 2x minus 16. Then we'll go ahead and add over the 16. So that will now be that 28 is equal to 2x. I'm just going to copy that over here to give myself a little bit of space to do the last step, which is to divide by 2. And it looks like x is going to be equal to 14. Okay. This next one is actually pretty easy. Notice that both of our angles, both the 50 and the x, have the same intercepted arc. And remember, when that happens, the two angles have to be equal to each other. So then x would have to be equal to 50, and we are actually done. So pretty quick on that example. A little bit more interesting example is when we need to look for a variable, but the same idea still applies. Notice that both this angle right here for B and this angle right here for D both share the same intersected arc right here. So what we can do is we can set those equal to each other. So 2x is equal to 5x minus 81. So then to solve that, let's get all of our variables to one side. So let's subtract 5x from both sides. That'll be that negative 3x now is equal to negative 81. And then divide both sides by negative 3. And that'll now be x by itself is equal to 27. All right, so let's talk about some special cases now. Our first special case is when an angle is inscribed in a semicircle. So when an angle is inscribed in a semicircle, it's basically an angle where the vertex is on the semicircle and the chords are the circle at the endpoints of the diameter. In other words, if you have, again, this angle right here, which is angle C, So angle AB or ACB is inscribed with the AB is the diameter. So again, a kind of special case here. When that happens, if you think about it, a semicircle is 180 degrees, so our inscribed angle should be half of that. In other words, an angle that's inscribed in a semicircle is always going to be a right angle. In other words, if we know that AB is the diameter, then what we can say is the arc AB is equal to 180 degrees, and that means that the measure of angle C would have to be half of that, which would have to be 90. Okay. So, using that information, let's solve for a couple of variables. In this case, y is our inscribed angle, and right away we know then that has to be equal to 90 degrees. To find x, we can use the fact that this is a triangle, so the angles have to add to be 180. So if we take x plus 2x plus y, which is 90, that has to add up to be 180. So then putting together x and 2x, that's 3x plus 90 equal to 180. So now we'll go ahead and subtract 90 from both sides. So that's that 3x is equal to 90. And then if we divide by 3, we'll get x by itself is equal to 30. Okay, this next example is even easier. Notice that each of these angles is inscribed in a semicircle. That means that they are all equal to 90 degrees. So x is 90, y is 90, and z is 90. Okay, so the last property that we'll look at for angles and for figures which are inscribed in a circle is going to be for quadrilaterals which are inscribed in a circle. So if you have a quadrilateral which is inscribed in a circle, then the opposite angles are going to be supplementary. And so just as a reminder, supplementary means that they have to add up to be a straight angle or they have to add up to be 180. In other words, looking at this diagram, and again, it said opposite angles are supplementary. That would mean that the measure of angle 1 plus the measure of angle 3 has to add up to be 180. And that also the measure of angle 2 plus the measure of angle 4 also has to add up to be 180. So then let's go ahead and use that information to work through a couple examples. So for this first example, let's go ahead and look at, let me get to the right example here. There we go. So yeah, for this first example, let's go ahead and find x and y. We'll start with x. So we know that x and 77 have to add up to be 180. So if we take 180 minus 77, that's 103. That's what x would have to be equal to. And then we'll do the same thing for 60 and y. We know that those have to add up to be 180. So if we take 180 minus 60, that's 120. That would have to be what y is. Okay, so pretty quick, pretty easy. Let's do another example. On this next one, for x, we have to add that with 80 to equal 180. So again, we'll just continue to take 180 minus the angle we know. That's 100 degrees. That's equal to x. Then for y, we've got 75 and y, which means that we'll take 180 minus 75. That's 105. That's what y would have to be equal to. Next, it asks us to find the measure of angle z, or measure of arc z. So looking at the inscribed angle, that would be the 80-degree angle. Remember that the arc is double that, so the entire arc from this point around to this point would have to be 160. We already know that this part of that was 50. So if we take 160 minus 50, that would be equal to 110. And that would have to be what z is. All right, I think one more example and we'll be done. So in this last example, we're only asked to find the variable x. To do that, what we'll have to use is the information that these two angles have to add up to be 180. And so that would mean if we take 180 minus 79, that's 101. Oops, let's write that correctly, 101. That has to be equal to not x, but 21x minus 4. So since we didn't have x, but 21x minus 4, that's why we have to set up this equation. And then to solve that, let's go ahead and add 4 to both sides. So that would be 105 is equal to 21x. And then to get x by itself, just divide both sides by 21. And we'll get that 5 is equal to x. All right, guys, I think that is about all we've got for today. In the next section, we'll talk about angles and arcs of circles, and we'll continue to kind of summarize everything. Until then, have a great rest of your day.